I recently got to interview Babak Falsafi, a food professor of the IC School at EPFL and founder of EcoCloud.
EcoCloud, we started EcoCloud about 4 or 5 years ago. It's a group of faculty at EPFL working on large-scale IT services. We've been, as of the past few years, focusing on data center design. We're looking at technologies from machine learning all the way down to infrastructure, so this spans the School of Computer Science, Computer Communication Sciences, all the way to engineering. We span into mechanical engineering, looking at heat exchange and cooling. We have experts who do liquid cooling. We're looking at generating electricity, storing electricity, and managing the entire electrical ecosystem in data center, but then going all the way up to the stack into computer science. We look at computer architecture, and then we have folks looking at networking, operating systems, databases, language design, and then all the way to machine learning. We have a consortium of companies that we work with in groups, and these are companies that span technology providers, even cloud providers like Google and Microsoft, but also technology companies like Intel and HP, infrastructure companies such as Eaton, and then all the way to users of users of cloud computing and users of IT, like insurance companies, AXA, which is the largest insurance company in Europe, and banks like Credit Suisse.
How did EcoCloud get started?
We started with mature projects, by now mature projects on liquid cooling. So there was a collaboration between EPFL and IBM Zurich, where they design and prototype a three-dimensional chip, which had silicon intertwined with liquid cooling conduits together.
The design of liquid cooling was a collaboration with Professor John Thome and Professor David Atienza.
It was sort of proof of concept to show that you can improve heat removal and allow for power envelopes that are order of magnitude higher than what you could do in silicon today.
And as you can probably feel it by touching your computer right now, computers tend to heat a lot. This is actually one of the main limits to computer performances. So as you can imagine, a new technology to efficiently cool computation devices is very valuable.
Moving sort of forward, one of the technologies we identified early on, which was missing, was platforms for benchmarking server efficiency. That we had for many years used database systems as a way to benchmark servers, but as of about 8 years ago, the use of data analytics and data management became widespread. There were open source software for such technology, so we started putting these together as benchmarks and representatives. What led to an effort which became Cloud Suite, which is now an industry sort of integrated platform for server efficiency analysis, part of Google PerfKit consortium for cloud efficiency analysis.
And this is very important. If you want to optimize your machine, you'd better have a way to measure the performance of your machine. And once you start tracking the performances of your machine, you can then better optimize it.
And then that led to a study where we proposed server silicon organizations, custom silicon for some of these services that are widespread in data centers, first-party workloads such as web serving, data serving, web search, embedded search. And there's a company out there, Cavium Networks. They build networking hardware. They actually took our design, which was blueprinted at EPFL, and that led to the ThunderX processor.
So this is a hardware technology, but there are as well plenty of software technologies.
There are technologies from groups such as Ed Bugnon's group looking at how do you build custom network stacks. This is all software. If you're interested in rack scale in-memory computing and Memcached, which is a common service that Facebook, for example, uses it in their software stack. And you have a protected user level networking, which bypasses your Linux networking technology. you can get an order of magnitude improvement with protected networking just for a Memcache service. That was a paper that appeared in OSDI a few years ago, which was the best paper award.
This technology allows efficient communication between servers by achieving high throughput of data transfer, low latencies between requests and replies, and strong protection from bugs and crashes.
Moving away from that, looking into databases, we have Christoph Koch.
We interviewed Christoph Koch in previous videos.
If you're interested in databases for a specific class of queries, you can use domain-specific languages to build custom query engines on the fly. And these custom query engines will not be able to handle all of the types of queries that are out there, like general-purpose database software, Oracle, DB2. But for a given class of queries, let's say web analytics or high-frequency trading, or data center monitoring, you can get orders of magnitude improvement in efficiency.
Finally, in recent years, huge data centers have found new applications in machine learning, as learning with so-called deep neural networks require huge computation times. Here again, faculty members of the IC2 at EPFL and at EcoCloud are working hard and achieving major breakthroughs in their respective fields.
And then moving away from that into machine learning, we have Volkan Jever, who is looking at accelerating algorithms for big data. He has training algorithms for deep learning that improve in complexity as you give him more data. So the amount of computation per datum decreases as you go to larger depositors of data for training. And this is a great opportunity for big data center hosts and cloud providers, because right now the way they train their deep learning networks is that they just use a hammer. They throw more resources at the problem, and with more data, they require more GPUs and more hardware to solve the problem.
With big data, the key challenge there is that data is actually growing at a faster rate that conventional technologies could even sustain.
More and more companies will have to try to go to larger cloud providers, maybe public clouds